And here we are on rotations, page 2. And to figure out the rule, example 2 again, we're given the image and the pre-image. We want to figure out the rule. So what I did is I took the same letter, G and G prime, and I connected it to the origin. And you can see it forms a straight line. Well, a straight angle is 180 degrees, so we are rotating 180 degrees. And you don't have to say about the origin. We're assuming it's about the origin for these problems. So example 2b, I just picked one of the letters, so I chose letter L, and I connected it to the origin, and I connected L prime to the origin, and this is a 90-degree angle. But now here's where you have to be careful, because you can't just say rotate 90 degrees. You have to say either clockwise or counterclockwise. And so here's L prime. So it went this direction, and this direction is counterclockwise. So rotate it 90 degrees counterclockwise. All right, and the last thing is rotational symmetry. And this is in this section because rotational symmetry is a rotation. We're just rotating the object directly on top of itself. Okay, so we're like spinning a piece of paper. Put your pencil down in the middle of your piece of paper and spin it until it lands back in the same, looking the same. All right, so rotational symmetry. The shape turns at most 180 degrees and lands on itself. Here's the key, at most 180. We don't go over 180 because if you go over 180, then you should have just turned it the other direction and it would have been shorter. Okay. So here's kind of how I think about this is I do a whole circle. I want to get this purple point back to itself. So how many small turns could I do where the shape looks the same and get back around? So if I put the purple point here, the square would again look like the same square. If I put the purple point here, it would look like the same square. If I put the purple point here, it would look like the same square. And then if I move it, I'm back to my original spot. So that's 1, 2, 3, 4 small turns. Well, a whole circle is 360 degrees. So 360 divided by 4, each of those turns is 90 degrees. So from here to here would be 90. Plus another 90 would be 180. And then if I added another 90, that would be 270. So I don't add another 90 because we don't go over 180. Okay, so you stop at 180 or less. You never go over 180. Okay. All right, so here's a regular star. Regular means all the angles and segments are the same. So it's not like you have some segments that are 2 inches, some segments that are a foot. They're all the same length, all the angles are the same. So here's my purple point, and I'm going to move it until I get it back to the original spot. But I want to figure out how many small turns would the star land on itself. So if I move the purple point here, the star would look the same. If I moved it here. So each time the purple point lands on one of the vertices, the star would look the same. So this is 1, 2, 3, 4, 5, 6 small turns to complete a whole circle. So 360 divided by 6 is 60 degrees. And then if I did another small turn, that would be a total of 120 degrees. If I did another small turn, that would be a total of 180 degrees. If I did another small turn, that's over 180, so I don't want to do that last small turn. Okay, so as soon as it goes over 180, you are done, and you always have to list all of the possibilities, not just the first one. Okay, so 90, 180, 60, 120, 180. Okay, so you have to list all of them, not just the first one. And that finishes up page 2 of rotations.